Okay, students, welcome once again. So, we were doing some questions exercise based on multiplication of matrices. That is what we have started in this session. And we have also solved some exercise questions based on matrix multiplication. So, in that sequence or in continuation, let us have another case or another example. If the matrix equation this is a matrix equation. I have just told you in the beginning or in the last slide, matrices are written in the form of equation, then they represents a matrix equation. For example, if I write x square plus 3x plus 5, this is equals to 0. We know this is an equation in the variable x, right, because x is a variable, and of course this is a quadratic equation. If I replace this variable x here in this equation by any matrix, then what will happen? Say x is being replaced by a matrix A. So what we will get here, a square plus 3a plus 5 is equals to 0, right? A is a matrix, a square is a matrix, because a is multiplied with a, you will get a square. 3a is also a matrix because it is a scalar multiplication of a matrix by 3, but 5 is a number. So matrices can be added with a matrix. Matrices cannot be added to any number. So in place of 5, what we do, we use it here 5 of I. I is an identity matrix, and I, you know, I is equals to 1 0 0 1 if order of A is 2, and I will be equals to 1 0 0 0 1 0 0 0 1 if order of A is 3. So order of the identity matrix will be exactly equals to the order of the matrix. So this equation actually known as matrix equation, right? So here in this session or in this chapter, we will solve various matrix equation as we solve the equations for the variables in our earlier classes. Clear? So this is also the case of a matrix equation. This is a matrix equation. So this is a matrix multiplied with a matrix x. Here this x is a matrix. It's not the cross, right? The product of the first matrix, this 4 1 3, it's like this. 4 1 3 is a matrix, right? This matrix is multiplied with the matrix x, then the product is coming out to be this matrix, minus 4 minus 1 minus 3, 8 2 6 4 1 and 3. Are you getting the meaning what I want to say? So the left hand side contains two matrices 4 1 3, this, and the right hand side contains this matrix. So product of this matrix and this matrix is equals to this matrix. This is a matrix equation. Then what you have to do? Find out the matrix x, right? It's very much similar to x is equals to 6. Then find out x. X is equals to 6 by 2, that is 3. We did in case of numbers. But I have told you in the very beginning, matrices behaves like numbers, but they don't follow the law of division. Law of division is valid in case of numbers, but the law of division is not valid in case of the matrices, right? So we have to find out the matrix X, right? See, if we take A as the matrix this, if we take A as this matrix 4 1 3, right? Let A is this, and we take B as this matrix, minus 4 minus 1 minus 3 8 2 6 4 1 3, right? This is matrix B. So okay, this is B and this is A. Let A is this and B is this. Then the above equation, see, this equation can be written as AX is equals to B. Clear? We have taken this matrix as A, this matrix as B. So AX is equals to B. This is a matrix equation. Clear? And from this matrix equation, we have to find out the value of x, right? So see what we have to do. We cannot divide the matrix B by matrix A to find out the value of x. Yani we can't write like this, B is equals to x is equals to B upon A. No, this is not valid because division is not there in case of matrices. So what we should do? See, this is your left hand side, right? This is your left hand side and this is your right hand side. Right hand side is known. In the left hand side, we know the matrix A, but we don't know the matrix X. Anyhow, if we determine the matrix A's order, matrix A's order means what should be the order of the matrix A so that A and X can be multiplied. Then we multiply A with X, we will get a matrix. Then the left hand side matrix will be equals to the right hand side matrix, and then we can very easily use the idea of or the concept of equality of two matrices. Two matrices are equal if their corresponding elements are equal. Yes, are you getting the approach what I want to do? See, this is our left hand side AX, this is our right hand side. The right hand side is completely known, but the left hand side is not completely known. Rather, A we know, but X we don't know. And what we are doing in left, A is multiplied with X. So if anyhow we are able to determine the order of the matrix X such that A and X can be multiplied, then we can multiply AX to get the left hand side matrix. Then we can equate the left hand side matrix is equals to right hand side matrix. Clear? So order of A is what? Order of A is A contains 3 rows and 1 column. And order of B, the right hand side is what? 3 by 3. We multiply A with X. So A contains 3 rows, 1 columns. Then how many rows X must contain? X must contain number of columns of the first matrix, that is A, should be equals to number of rows of the matrix, second matrix, that is X. So A contains 1 column, therefore X must contain 1 row, right? It is clear. If we take what should be the columns in B, if we take it as 3, see what is the condition? The order of A is 3 by 1, and if we take order of X as 1 by 3, see, this is the condition of multiplication. Columns of the first should be equals to rows of the second. And 3 by 3, this is what? This is the order of the product AB, AX, right, or AB. So AX will be a matrix of order 3 by 3 and B is also a matrix of order 3 by 3. So we can say that the order of the matrix X must contain 1 row and 3 columns, right? And understand? See, the above equation can be written as AX is equals to B, and we have to find the matrix X. First, we find the order of the matrix X. Since A is 3 by 1 matrix and B is a 3 by 3 matrix, therefore, X is a matrix of order 1 by 3. So, X must contain 1 row and 3 column. This you can understand by the concept of the order of a matrix under which two matrices are being multiplied. So, X must contain 1 row and 3 columns. So, let us take any matrix having 1 row and 3 columns. Let us suppose X is taken as 1 row A, B and C, right? This is a matrix which contains 1 row and 3 columns. So, this we have taken as X, right? X is taken as A, B, C. Now, what we do? AX is given as B. What is A? A is 4, 1, 3 and X is taken as A, B, C, A, B, C, and this product is equals to which matrix? That is -4, minus 1, minus 3, 8, 2, 6, 4, 1 and 3, right. Now multiply these two matrices. How you will multiply this? See, the first row is only one element, that is 4. 4a, 4 with A, 4 with B, 4 with C. The first row of A should be multiplied with all the three columns. Then the second is 1. So 1 with A, that is A, 1 with B, that is V, 1 with C, that is C. Now the third, 3 with A, that is 3A, 3 with B, that is 3B, 3 with C, that is 3C. This is the product of the matrices 4, 1, 3 and A, B, C, and this is equals to minus 4, minus 1, minus 3, 8, 2, 6, 4, 1, 3, right. So this matrix is equals to this matrix, and we know that if two matrices are equal, their corresponding elements must be equal. So corresponding elements means from here A is minus 1, this is A, this is minus 1, B is 2 and C is 1. So the values of A, B, C are minus 1, 2 and 1, and what we have taken x, put the values of A, B, C minus 1, 2 and 1. So x is this matrix such that if 4, 1, 3 is multiplied with this matrix, then the product of these two matrices will be the matrix which lies in the right hand side. Clear? This is how we can solve any matrix equation to find out the value of any specific matrix in a very similar way as we generally do in case of general equations, right? Take this one also. This is also a question of the same type. Find the value of x such that, see, this is matrix 1 and this is matrix 2 and this is matrix 3. And what is given here? The product of all these three matrices is 0, where 0 is not a number. Here 0 is a null matrix. Null matrix means a matrix whose all entries are identically 0, right? So this is also a matrix equation. So from this matrix equation, find out the value of the x. So what does it mean? What you will do here, what you conclude, right? See, this is what in the left hand side we are having three matrices as highlighted, right? Matrix 1, matrix 2 and matrix 3. And what is given here, the product of these three matrices is a null matrix. So what should be the value of x so that the product of all these three matrices should be equals to a null matrix? This is what we want to do in this question. Are you getting the objective? What is the objective of finding out the solution of this? So the product of the matrices which lying in the left hand side, it should be equals to the right hand side, that is a null matrix. So it's up to you. You have to multiply these three equations. Now it's your choice. Either you multiply equation, either you multiply matrix first with matrix second, then multiply matrix third, or you first multiply matrix third and matrix second, then multiply matrix 1, because we know the property ABC is always equals to ABC, right? If you want to multiply three matrices, multiply AB first, then with C, or BC first, then with A. In both way, you will get the same result, right? So see what they are doing here. We are given, this is our question, given, right? So what they did, they multiply second and third matrix first. See, second and third matrix is what? Second matrix 1, 2, 15. 3, 5, 3, 2, 1, 2. This is matrix second, and matrix third is 1, 2, x, right? Multiply these two. What is the product of these two? So matrix A is of order 3 by 3. Its order is 3 by 3, and its order is, what is the order of this? Its order is how many? It contains 3 rows and 1 column. 3 rows and 1 column. So the condition for the product is this. It is already satisfied. columns of the first matrix are equals to the rows of the second matrix, so we can multiply them. So see, multiply the first row of the first matrix with the column of the second matrix. See what you will get. 1 into 1 is 1, 3 into 2 is 6, 2 into x is 2x. Clear? The first row should be multiplied with the column. Then the second row should be multiplied with the column. 2 into 1 is 2, 5 into 2 is 10, 1 into x is x. Now the third row should be multiplied with the column. This is 15. Okay. 15 into 1 is 15 plus 3 into 2 is 6 plus twice of x. So see, this is the product and this is the product. So what you will get here, this is equals to 7 plus 2x, 12 plus x, and 15 plus 6, 21 plus twice of x. This is the product of second and third matrix, right? We are getting the same matrix here. Now we will multiply the matrix 1 x 1 with this matrix. 7 plus twice of x, 12 plus x, and 21 plus twice of x, right? Again check whether the product is possible or not. So this is a matrix of order what? Its order is what? It contains 1 row and 3 columns. So 1 by 3, and this matrix contains 3 rows and 1 column. So our condition for the product is satisfied, right? Clear. And what is the order of the product? If we multiply these two matrices, the product will be of order 1 by, this will be the order of the product. That will contain 1 row and 1 column. See, the product is like this. 1 into 7x is what? Multiply this row, this is only 1 row, this is only 1 column. To multiply this row with this column, multiply 1 with 7 plus 2x, so you will get 7 plus twice of x, plus multiply x with 12 plus x, so you will get here 12x plus x raised to the power 2, right? Multiply 1 with 21 plus x plus 21 plus twice of x. This is the product of these two, and then simplify it. What you will get here, x square plus what you will get, 21 or 8 is 16x, right? 12 plus 2 14 plus 2 16 plus 7 plus 21, that is 28, right? This is equals to 0. Now try to understand this trick. This is very important. Now I have told you in the very beginning, if I write 1, this is a number. If I write 1 like this, now this is a matrix which contains 1 row and 1 column, and now 1 is an element of the matrix. So see this here, this equation is written like this. So this is a matrix having 1 row and 1 column, whose element is x square plus 16x plus 28. So this matrix is equals to a null matrix. It means their corresponding elements should be equal. So this will imply that x square plus 16x plus 28, this is equals to 0. Now this is a number. Here it is the element of the matrix, and this 0 is a null matrix. But when two matrices are equal, their corresponding elements are equal. When we use the concept of equality, now this is an equation and this is now equals to 0. Now you can find out the solution of this equation. This is a quadratic equation. So find out the factors, two factors of 28 whose sum is 16. So 28 means 2 into 14 is 28, and 14 plus 2 16. Yes, this can be written as x square plus 14x plus twice x plus 28 is equals to 0. Now take x common, x plus 14 is here. Take 2 common, x plus 14 is here. This is equals to 0. So what we will get, x plus 2 and x plus 14, this is 0, and this implies x is equals to minus 2 and minus 14, right? These are the two values of x for which this matrix equation is satisfied. It means if we take here minus 2 in place of x as well as here in place of x are minus 14, then the product of the three matrices lying in the left hand side will be equals to a null matrix, right? This is also another case of the same type. If A is a matrix this and B is a matrix this is a matrix A and this is a matrix B, then find the values of A and B such that AB is equals to B. So no problem. We have given two matrices, very simple. What is given here? We have given A and we have given B. What is given further? AB is equals to BA, right? Find out AB, multiply A with B, find out AB, multiply B with A, find out BA. AB and BA both are obtained. Then as per given condition in the question, AB and BA both are equal. So equate these two matrices and we can use the concept of equality of two matrices. We can get the values of A and B. So it's very simple. Since both A and B are square matrices, therefore AB as well as BA both exist. We have nothing to check about the order of multiplication, right? So AB, if we multiply A with B, we are getting this matrix, and if we multiply B with A, we are getting this matrix, right? What is given here? AB is equals to BA. So AB this matrix, BA this matrix, both matrices are equal, and you know if two matrices are equal, it means their corresponding elements are equal. So what we want to calculate here? So what we will get corresponding elements means 3A plus 6. This element should be equals to this, that is 3A plus 4B, right? 3A plus 6 is equals to 3A plus 4B. Now second is this should be equals to this 3B plus 10, this is equals to 2A plus B, right? Now you can solve these two equations to find out the values of A and B, and solving these two, A is coming out to be 13 by 2 and B is coming out to be 3 by 2. See how you will get this. 3A and 3A will cancel out. What you will get? 4B is equals to 6. This implies B is 6 by 4. So 3 to 3 the 6, 2 to the 4. So B is coming out to be 3 by 2. Now put the value of B in A. You will get the value of A. A will come out to be 3 by 13 by 2. Right? So this is how you can find out the values of A and B. This is also a very good question of the same type, how the matrices satisfy an equation, right? See, fx is given as the equation like this. This is a general equation of numbers. X is equals to x square plus 3x plus 2, right? This is a function or equation. Then determine the value of fa if a is given like this, right? If I ask you fx is this, then determine the value of fx, determine the value of fx if x is 5. So what you will do? You will simply put x is equals to 5 in this equation. What you will get? 5 square plus 3 into 5 plus 2. So f5 will be what? 25 plus 15 plus 2. So 25 plus 15 is what? 30, 40, 40. This is equals to 42, right? So the value of the function or equation x square plus 3x plus 2 is 42 if x is equals to 5. But here what we want to do? Then determine the value of fa if a is this. So naturally, if fx is this, then what is the value of fa? Replace x by a in the given equation. Fa will be what? A square plus 3a plus 2. And I have just told you in the last slide, a number can never be added to a matrix. Therefore, we multiply a number always with identity matrix. So f of a is equals to a square plus 3a plus 2i, where I is an identity matrix, right? This I is identity matrix. So FA means this. So find out the value of a square first by doing what? Multiply a with a, you will get a square. Find out the value of 3a means multiply 3 with the matrix A, you will get 3a. Twice of I is what? Multiply 2 with 1, 0, 0, 0, 1, 0, 0, 0, 1, right? This matrix. So what you will get? Twice of I will be equals to 2, 0, 0, 0, 2, 0, 0, 0, 2. So this is 2i, this will be 3a, and this will be a square. Substitute all these values of a square plus 3a plus 2i and then simplify it. You will get the required value of f of a, right? See, f of x is given as the equation this, right? Then fa will be this. Simply replace x by a in the given equation. So a square plus 3a plus twice of I is an identity matrix. The reason I have already told you, a number cannot be added to a matrix. Therefore, we will multiply the number by identity matrix, where I is an identity matrix of order 3. Clear? Now a square means a into a. Multiply the matrix A with matrix A itself as usual. The first row of the first matrix should be multiplied with all the columns of the second matrix. Then take the second row of the first matrix and multiply it with all the columns of the second matrix. Then take the third row of the first matrix and multiply it with all the columns of the second matrix. So by using this operation, finally you will get the product a square as this matrix. So we obtained a square. Now 3i simply means scalar multiplication of a matrix with number 3. So multiply the matrix A with 3 means all the elements of the matrix should be multiplied with 3, right? So 3a means 3, this is 6, this is 0, this is 0, this is 6, this is 0, this is minus 6, this is 12, this is 6. So this is the value of 3a. Now twice of I have already shown. Multiply simply 2 by your identity matrix, you will get the value of 2i. Now the value of fa, we know this, a square plus 3a plus twice of I. This is a square, this is 3a, this is twice of I. Say f of a is what? A square means, let us do the last line, 1, 6, 0, 0, 4, 0, minus 6, 12 and 4. This is your a square plus 3, 6, 0, 0, 6, 0, minus 6, 12 and 6. This is your 3a plus now 2, 0, 0, 0, 2, 0, 0, 0, 2. Add up these three matrices. So either add first one this and this, then the third, or add second and third, then first. In both way you will get the same result. So f of a will be equals to sum of all these three matrices. 1 plus 3 is 4 plus 2 is 6. You can also write directly like this, right? 1 plus 3, 4 plus 2, 6. 0 plus 0 plus 0, that is 0. Minus 6, 12 plus 0, that is minus 12, right? 6 plus 6 is 12 plus 0, that is 12, right? This is 6, 0, right, in a small way, 6, 0 and minus 12. Now 4 plus 6 is 10 plus 2, that is 4 plus 6, 10 plus 2 is what? 4 plus 6 is 10 plus 2, 12. This is 12, not 10. This is 12. You should write here 12. Now 12 plus 12, 24. This is 24, right? Now 0 plus 0 plus 0, this is 0, 0 plus 0 plus 0, this is 0, 4 plus 6, 10 plus 2, that is 12. So this is your FA, which we can calculate by using these properties, right? So student, I think I should stop it here. So with this question, the session is almost over. So thank you very much for your patience learning. Thank you.